The topic for Lesson 4.6 is functions. We'll learn how to determine whether a relation is a function and find function values. The table shows barometric pressures and temperatures recorded by the National Climatic Data Center over a 3-day period. Notice that when the pressure is 995 and 1006 millibars, there is more than one value for the temperature. That means it's not a function. A function is a relation in which each element of the domain is paired with exactly one element of the range. In a function, knowing the value of x, the independent variable, tells you the value of y, the dependent variable. For example, when they ask to determine if the relation is a function, if x is -2, they tell me y is -8. 0, 0, 2, 8, 4, 6. Absolutely, this is a function. Every value of x, I can find the value of y. More mathematically, each element of the domain is paired with exactly one member of the range. I think everybody's all right with either a table or a mapping showing the same information. If x is -7, they tell me a value for y, for x, for y, x, y. So sure, it's a function. Once again, each element of the domain is paired with exactly one element of the range. So now let's check this list of ordered pairs. If I have -5, I get a 2. If I have -2, I get a 5. If I have 0, I get a 7. Oh, or do I get a 9? I don't know. Okay, so that's going to be a no. The element 0 in the domain is paired with both a 7 and a 9 in the range. So if you give me a 7, I don't know what you want from me. Do you want a 7? Do you want a 9? You got to tell me what you want. So -5 is great. If you give me a -5, I will give you a 2. If you give me a -2, I will give you a 5. If you give me a 0 and I'm like, I don't know, 7, 9, I don't know what to do. So it is not a function. Functions are fun. We know what to do. You can use the vertical line test to see if a graph represents a function. If no vertical line can be drawn so that it intersects the graph more than once, then the graph is a function. If the vertical line can be drawn so that it intersects the graph at 2 or more points, then the relation is not a function. So this parabola crosses once. It's a function. Nope. And this guy's a little bit tricky, but if you look really closely, this is a closed circle and this is a open circle up here. So a vertical line will always only cross this one once as well. And a lot of times I will just take a pencil and put it across the graph vertically and make sure it'll go across. That is a good tip. For example 2, they ask us to determine whether x equals -2 is a function. Let's make a table of values. So, well, they only gave us one value for x. So I'm going to get 3 different values for y. Let's say it's -1, 0, 1. We like those numbers. So if we plot those points and draw the line, we'll get a vertical line. If we check a vertical line, at some point it is going to epically fail the vertical line test. Because a vertical line will pass it an infinite number of times. So that is not a function. Now this is a good one to practice our x and y intercepts we had in the last lesson. So if we substitute 0 in for x and solve for y, we'll get one nice little point. So 2y equals 12. So y is 6, so that's the ordered pair 0, 6, easy to plot. If we substitute 0 in for y, two times 0 is 0, so 3x equals 12, x equals 4, so that's the ordered pair 4, 0. If we plot those two nice little points and draw the line, now that we can see the graph, we can decide if it's a function. Does it pass the vertical line test? Absolutely. So I would say it is a function. That one was not. Equations that are functions can be written in a form called function notation. For example, consider y equals 3x minus 8. That could also be written as f of x equals 3x minus 8. In a function, x represents the elements of the domain, and f of x represents the elements of the range. Suppose you want to find a value in the range that corresponds to element 5 in the domain. This is written f of 5. The value f of 5 is found by substituting 5 in for x in the equation. So you've been doing evaluate problems for a long time. This is just a different form of an evaluate problem. If f of x equals 3x minus 4, find f of 4. So I'm going to write f of 4. Where there was an x, I put a 4. So on the other side, where there was an x, I'm going to substitute in a 4. So f of 4, that's an ugly f, equals 12 minus 4, which is 8, and we're done. Same rule. Find f of negative 5 this time, they said. So f of negative 5, 3 times negative 5 minus 4. Negative 15 minus 4 would be negative 19. Make my negative a little bit bigger. Now, what if we wanted to find f of an algebraic expression like 2 minus x? Not a problem. F of 2 minus x, in the parentheses, I replaced x with 2 minus x. So on the right side, I'm going to replace x with the same thing, 2 minus x. So all I have to do is distribute. So 3 times 2 is 6, minus 3 times x is 3x. And combine like terms, 6 minus 4 is 2. Those are the only terms I can combine, so I am done. Now I'm going to give you a secret. We can graph things that are not straight lines. If I found points for this algebraic expression, this function, and plotted them, I would have the graph of a parabola. So I'm going to find k of negative 3, which would be one of the points on my parabola. I'm going to take negative 3, square it, minus 4 times negative 3 plus 5. Negative 3 times negative 3 is positive 9. Negative 4 times negative 3 is positive 12. And 21 plus 5 would be 26. I'd need a big piece of graph paper for that one, but it could be done. Here we're going to evaluate another interesting one. So we're going to do k of 6z. So I replaced the m with 6z. So the m that's here I'm going to replace with 6z. I'm using parentheses because m, the whole value of m was squared, so I need the whole value of 6z to be squared. And I'm just using parentheses there because they look nice. So 6z times 6z is 36, z squared, minus 24z plus 5. I have no like terms, so actually this is easier. I am done. Third problem with the same rule, k of m still equals m squared minus 4m plus 5. This time they want me to find negative 4 times k of y. So every place there was an m, I'm going to put a y. That looks messy, but I'm trying to make a point. So it's going to be y squared minus 4y plus 5. All I have left to do is distribute, and I have negative 4y squared. Negative times negative is a positive 16y, and minus 20. I have no like terms. I cannot combine them. I am done. Oh no, it's not enough for them to give us one new notation with f of x, k of m, all of those. You could also see function notation written with other interesting symbols, like they use these little less than and greater than signs. Another common odd one that they'll see on a standardized test is the pound symbol. So if you have a pound B or something like that. it gives you a rule to do with the variables for a and b. So in this one, it means the same thing as f of x. Where there was an x, I'm going to replace it with -5. So I have 3 times -5 squared, plus where there was an x, I'm putting -5 minus 1. So all I have to do is simplify that. 3 times -5 times -5 is positive 25. Minus 5 minus 1. 3 times 25 is 75. Minus 5 minus 1. 70 minus 1 is 69, which is choice A. In summary, a relation is a function if each element of the domain is paired with exactly one element of the range, and substitute values in for x to determine f of x for a specific value.